Hello, in this video we look at normalizing point clouds. Normalizing a point cloud means changing the vertical reference of the point cloud data to be the ground surface so that the z-values of points in the point cloud data are height above the ground surface. Okay, so let's get familiar with the point cloud data that we'll be using. Let's load the data. Point cloud data. I'll go to the folder that have this data. It's a point cloud for data for a forest area. Once you load a point cloud data, you will see a tab in the Imagine River interface, a point cloud tab that basically gives you all the tools that you can use to interact with a point cloud data, and also tools for volume computation, classification, and much more. So let's right click on the data and name and see the information about this point cloud data. Now, from the point cloud metadata, you can see that this data has about 4.8 million points. Its horizontal projection is UTM zone 10, and if we look at the vertical reference, the data is referenced to WGS 84, and what we want to do now is change the reference from WGS 84 to the ground surface. We can also look at each point. If we go to the table tab and then click on show attributes, it will load the cell array at the bottom of the workspace that shows you the XYZ coordinates of the points and some more information about the points, their intensity, return type, and if you have other attributes or metadata, they will also be displayed. But we see, based on the WGS 84 data reference, the z values are in the 300 plus value. So what we want now to do is change the reference to the ground surface so that this z actually reflects the height of the points above the ground surface. We can also look at this data from a side view. Go to the point cloud ribbon tab and pick the rectangle profile tool, and let's draw a box at some extent. And once you draw the box, the side view profile windows will open, loading the data that's selected in the box from the side view and the front view. Let's fit this to the screen, giving us more details. From the side view profile viewer, we can also do measurements. Let's assume we want to measure the height of the tree, and I will make this viewer active. Click on the measure profile. That will load the side view profile cell array that will record the measurements that we are going to do. Let's go to the viewer and single click to start the measurement and double click to end it. Now that measures the height of this tree, and you can see the height is about, well, it says 39 meters or 39 units. It's reported in the units of the point cloud data. What's noteworthy to note here is you have the start z and you have the end z, and the height is basically computed by subtracting the end z from the start z. If we had the point cloud data that's referenced on from the ground surface, we don't have to do this kind of computation, because the point z will basically be the height of the point above the ground surface. and that's why we are gonna normalize this point cloud data. We can also visualize the point cloud data in 3D. Let's close the 2D viewers. Close that, and we don't need the cell array. That will close everything, and let's clear the box from the display, and then let's click show 3D, and this will display the point cloud data in a 3D viewer. You can hide the 2D viewer, giving you more space to display the 3D viewer, and that way you can play with other attributes, like for example, instead of looking at the points, we can look at it as a surface that shows you the trees and areas where there are no trees. To perform point cloud normalization, we need to have the bare earth surface model of the area. We have a raster DEM that represents the bare earth surface of this area. Let's load that raster model. Let's go to File, New. We'll load it in a new viewer. Again, we go to File, Open Raster as Image Chain. Let's go to the data folder, and let's load the bare earth DEM for this area. Okay. Once it's loaded, we can go to the panchromatic tab and change the display style so that it shows as relief, and let's fit the screen for both cases. Now you can see now the right is the bare surface of this area. On the left you have point cloud with height above the WS84 ellipsoid. What we want to do now is normalize this point cloud data using this raster dataset. Alright, now let's create a point cloud data, a normalized point cloud data, and we'll do this in the spatial model editor. Let's close all the viewers and create a new spatial model editor. The model we are going to create will read a point cloud data, a raster data, and then normalize the height and write out a point cloud data. So we need operators that can read point cloud and raster data. So let's go to the input category, and we'll pick raster inputs. We'll have raster input, drag that, and let's go to the point cloud category, pick point cloud input. That the operator that does the normalization is called normalize height. Let's drag that operator, and then once the normalized height point cloud is created, we want to write it out to a file. So we have 4 operators, and let's connect it. File read, connect it to the point cloud port, and the raster will connect it to the ground elevation port, and once it's processed, we'll connect it to the point cloud port of the point cloud output operator. Let me just fit this. Okay, we'll have that. Now let's double click here, go to the folder that has our point cloud data. Same thing for the raster. I'll go to the folder that has the bare earth, and double click to specify an output file. I'll give it a name, normalized forest point cloud. That's right? So that's what we have. Let's save this. Again, we'll go there. I already have it, but I'll overwrite it in this case. So, and once we have created it, saved it, and next is, of course, let's run it. All right, the data is generated. Let's take a look at it. Let's close the spatial model editor window and create a new viewer and open the point cloud data, the normalized point cloud data. All right, and once it is created, let's look at metadata. The previous data, the unnormalized point cloud data, z value was in the range of 300 plus. Now this one, if we go to file metadata, we'll see the mean z and max z are, the maximum is 57 meters, and the elevation, if we look at that, previously it was WGS 84, now it's undefined because it's a ground surface. That's a local ground reference data. Okay, we can also look at the points, go to the table, show attributes. Again, the z value is now 0 and 30 and 40 according to the height of the point above ground surface. Like we did previously, we can also get to a box and see profile views. You can see the side view profile and the front view profile. Let's do measurement, and I will make this active one. I'll measure make the active one. Let's measure from the bottom to the top. Now you see the height, the exact height, and you don't need to do computations to get your height value, or you don't need to do measurements because it basically since the value of the points are actually height above ground, you can take that as for other analysis. This concludes our demonstration of normalizing a point cloud using ERDAS raster DM. Thank you.